Alright, this is for AP2, and this is your second recording for the electrostatics unit, and this is over Coulombs law. Well, Coulombs law is actually the very first formula on your formula chart in the electricity and magnetism area, but it doesn't look the same way as I'm about to present it. So this is just form 1 of Coulombs law. Now, Coulombs law tells us how the magnitude of the force between two particles varies with their charge and with the distance between them. This is very similar to the universal gravitational force between two objects and using the universal gravitational constant. But we use Coulomb's constant, which is our K value, and on your formula chart, it is actually 9 times 10 to the 9th Newton meters squared over Coulombs squared. So even though on here it says 8.99, we will use 9.0 because that's what it says on your formula chart. And then the Q's are for charge, and they are in coulombs. R is for your distance between the charges, and it will have to be in meters. And then F will be in force. There is your force, and it'll be in newtons. So this is the most familiar one that you might have seen before, which we've talked about in our previous classes. Coulomb's law applies directly only to spherical, symmetrical charges. So it's really important that you understand that. Now the second law is the one that the second form here is the one that you see on your formula chart. And it has your 1 over 4 pi epsilon naught. And that epsilon naught is actually your vacuum permeability. And so it's just a different way by doing it 1 over that vacuum permeability and 4 pi of writing your Coulomb's constant. So if you look on your formula chart, it has Coulomb's law constant on the front in the constants and conversions area. And it says K equals 1 over 4 pi epsilon naught, which equals the 9 times 10 to the 9. So it's really just the same way of doing it. So K equals that. So if you need to know it, it's on the formula chart as well. The epsilon naught is. So then we have our Q's still. They still mean charge, and they're in coulombs. And your R is still your distance in meters. F is still your force. So you can use it in any format that you want. You just need to remember that the K format doesn't show up on your formula chart. So symmetrical spherical forces, or the inverse square law rule. Remember, we had the universal gravitational law for Newton's law, and we have Coulomb's law for electrostatic forces. They're the same in the fact that they're talking about two spherical forces, or two spherical objects, and we're talking about the distance they are away. So it is directly proportional to the charges, okay, and it's inversely proportional to the square of the distance between the charges. So if the magnitude of the charges goes up, then the force also goes up. But if the distance between them goes up, then the force is going to decrease by that amount squared. So it's important that you remember what the inverse square law means. So we have a sample problem here, and we have a point charge that's positive 12 microcoulombs, and it's going to experience an attractive force of 51 millinewtons when it is placed 15 centimeters from another point charge. Okay, I literally do, even though this is going to be popping up and it being worked out, I want you to skip this slide. We will actually be doing this problem in class. Okay, superposition is talking about when electrical forces, which are like any other forces, are a vector quantity. When we have to put them together, then we're going to talk about that we're going to do vector addition. So if a charge is subjected to forces, more than one force, or more than a force from more than one charge, then vector addition is going to be performed. Vector addition, to find the resultant vector, is sometimes called superposition. So it's just like what we've done before. If they're both in the same plane and going in the same direction, then you're going to add them together. If they're in the same plane but going opposite directions, then you're going to subtract them. If they're in different planes, then you're probably going to have to use Pythagorean theorem and or trig to kind of look at your resultant vector. So just remember those things. So superposition is just when you use vector addition to find a resultant. All right? Again, we're going to do this problem in class, so please just go ahead and skip it, and we'll continue on. Bing, 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 bing. Okay. And we're going to skip this one too, and this one too. So, our examples, like I said, we're all going to do those in class. So I really just wanted to go over the basics of remembering some things. So just remember, you do know the Pythagorean theorem, you know your trig, and I really just wanted to introduce the formula, which is our F equals K Q1 Q2 over R squared. Even though that's not how it looks on our formula chart, that's the easiest way to use it. Our K constant is going to be 9 times 10 to the 9th. Newton meters squared over Coulombs squared, and our Q's have to be in coulombs, our R's have to be in meters, and we need to remember what the inverse square law is and how that affects the forces. So just an FYI, hope this helps.